Hello guys, welcome back. So we were discussing the cases of double black. In my previous video, I've already told you about these properties, that is how to delete a node in a red black tree when there arises a situation of double black. All right. But for convenience purposes and just for refreshing everything, I'll just be repeating all these properties once again. But in order to understand the basic cases of deletion in a red black tree, I suggest you please go and watch my previous videos regarding the properties of red black tree, insertion of red black tree, initial parts of deletion in red black tree. The link for the same is available in the description link. All right. So, as far as double black is concerned, that is actually, guys, the status of a node, right? Now, the question arises when we need to delete a black node. If a black node is an internal node, we can any which ways not delete it. Number one. Number two, even if we perform certain replacements and then the leaf node is black in color, still it is not recommended to delete that black node. Why? Because black node deletion can affect the black height in a red black tree. And that is, going against the properties of red black tree. That can be a violation in the properties of red black tree. That is why we need to take certain cases into consideration. Now, as far as point number uh, 2, 3, 4, 5 and concerned, that what happens when root is double black or any other node is double black, let me explain with the help of an example. So this is the example which we were discussing last time. All right, and let me explain everything to you once from the scratch. So let us consider that we have this red black tree which is given on the left hand side, that 10 is the root node, all right, which is definitely black in color, and we have node 5 which is black in color, 20 which is red in color, and 15 and 30 are black in color. Now let us say that let us delete, or let us try and delete node 20. So the question arises that can we delete 20 right now at the current state? No. 20 might be red in color, 20 might be having a color red right now, but 20 is at an internal node position. All right. So 20 cannot be deleted right now. And in order to perform deletion appropriately, what have I done? I have pasted all the properties on the upper right side. So 20 is red in color, but it is at an internal position. So what do we need to do? We need to replace the position of 20. So we can replace 20 with either node 15 or with node 30. All right. Now let us say if I try and replace 20 with its rightmost subtree, or with its the element at the right position. So what happens after replacement? 20 comes over here at the leaf position and 30 goes here. But even after replacement, the color of the nodes, they do not change. I have explained it to you earlier also, because 20 came over here at the position where 30 was there. So the leaf node is black, leaf node remains black, and 30 goes there where 20 was there. So the color of the node was red, so the color remains red. You remember I told you the example of, if we stay as a tenant in a house, the address and the properties of the house remains the same. All right. So replacement does not changes the color of the nodes. This is very important, guys. Any which ways, now what happens? If we consider node 20, or even if we consider node 15 for that matter, just understand it over here. I'm taking node 15. Why? Because we need to delete node 20. There is a reason why I'm saying that node 15 encounters a state, and that state is called a state of double black. How do we represent double black? I have mentioned two black circles across node 15. All right. So what happens? 15 was already black in color. Below 15, they were already the sentinel nodes. All right. So if I want to delete a node which is black in color, I just cannot delete them just like that. So when is the situation of double black? Situation of double black arises when consequently we have two black nodes. 15 is a leaf node, all right? But children of 15, which are the sentinel or the nil nodes, they are also black, all right? Now, can I say, just, in order to help you, can I say the root, that is 10, is also having a double black situation? I mean, not with respect to node 30 or 20, but with respect to node 5. Yeah, I mean, one case can be there, but with 15, both its children, that is the nil nodes, are black in color. So 15 is definitely encountering a situation which is double black situation. Am I clear, guys? Any node which is black in color and whose children are also black in color, then the problem of double black arises. Okay, fine. Any node which is black in color and its children are also black in color, then the problem of double black arises. So what happens? If the root is double black, we can simply remove the double black and we can keep one black node. So even if it is a situation like this root is black and there are two children which are also black, so even if it encounters a double black, we remove a double black and we keep a simple black. So this situation is more or less safe situation. So focus on the third point, that if any other node is double black, check if the sibling of the double black node is black and its both children are also black. Okay, so let us see. 15 is the node which is double black. Then what we need to do? We need to check if the sibling of the double black node, no, who is the sibling? Sibling of 15 is node 20. So node 20 is also black in color. Agreed? And see, notice. Check if the sibling of the double black node is black and both its children are also black. So ideally I can say, let me draw it over here in a more neat and clean way so that there is no issue at all. So I have this situation right now. And ideally I can say that I have nil nodes with respect to node 20 also, right? They are not available only with respect to node 15, but perhaps they are available also with respect to node 20 also. All right. So what happens? That when there is any other node, we check if the sibling of the double black node is black. Sibling of the double black node is 20 and it is also black. And both its children, that is the sentinel nodes, they are also black. In this case, what happens? In this case, the double black node gives one black color to its parent. If the sibling is also black and both its children are also black, then the double black node gives one black color to its parent. That means one black color is given to its parent. So it means that 10 and 5 was there, and now this 30 becomes black and this is 15. It has one black now, and seeing this, the sibling node which is already black, it becomes angry and hence its color changes to red. Now when 15 gives one black color to its parent, then what happens, guys? The node 20, which is the sibling, for instance, if you give a problem to your parents, so the sibling becomes angry. How dare did you give one black color to the parent? And hence its color becomes 20. So what happens? I will repeat once again. When the double black node checks the color of its sibling. Okay, so sibling of 15 is equals to 20. So sibling is also black in color, and the children of sibling are also black in color. So what happens in that case? The double black node gives one black to its parent. And who is parent of 15, guys? 30 is the parent of 15. So in this case, 15 gives one black color to its parent 30. So 30, rather than red, now its color changes to black. Okay, red to black. Okay, now when 20 observes that what is this? 15 has given one black color to my parent. He becomes angry, and that is why his color changes to red. Now, what happens actually, guys? Now, 20 has got red color. We wanted to delete node 20. So, what do we wanted? That 20 should be at the leaf position, and 20 should also have red color. And eventually, after executing all these points and properties of double black node, we eventually got 20 at the leaf position plus 20 is red in color. So now we can delete node 20. Okay. Alright guys, so this is how we handle the cases of a red-black tree with respect to double black node, and with this video we have completed all the basic properties of red-black tree, the concept, the properties, insertion of red-black tree, deletion of red-black tree. For other videos on data structures and algorithms, computer networking, discrete mathematics, and any prominent topics of computer science with respect to AKTU University, with respect to RGPV University, with respect to all the prominent concepts and university topics. Stay tuned to watch my videos. Thank you. And apart from that, I also want to mention one most important thing, that I will be conducting a live class on the introduction to data structures and algorithm next week, Saturday. So stay tuned for that information. Thank you, guys.